Okay, welcome. I'm Amharic, and this is a conference paper presentation titled as Design Sensitive Personal Information Detection and Classification Model for Amharic Text, which is authored by Tasfa Taganya and Amhara Gennetu or me. Here are the contents I'm going to discuss. Nowadays, organizations, companies, governmental institutes, non-governmental institutes, and individuals are favored electronic documents. This is because electronic documents are easy to modify, manage, and transfer. Here, the big risk and the big issue is that such electronic documents may hold sensitive information assets, and the sharing of such electronic document come with a disclosure of sensitive information. Sensitive information is a classified type of information that should not be disclosed, and if it is disclosed, it have its own economical, mental, or other form of losses to the owner of the information. Sensitive information can be organizational, governmental, a company, or personal. However, whatever it is, the domain is detecting the availability of sensitive content, and identifying its domain is highly needed to take the required action. That means to take the required action means to protect the sensitive information content. In this study, we have narrowed our scope to only sensitive personal information, and among sensitive personal information we have selected only health information, ethnic origin, and political view. When we see the problems which motivate us to do this study, many tools models were developed for different languages like English, Portuguese, and Spanish. However, such tools or another language tools cannot be directly used for Amharic language texts because of morphology, grammar, and semantic differences. And manual sensitivity detection is tedious, time consuming, and very expensive. And those problems motivated us to study on a tool or a technique for detecting and classifying sensitive personal information for our local language, Amharic. This work have three main significances, but not limited to these three. The first one is for providing different level of protection to information assets at information transit or at information transmission. Providing different level of protection may be needed, and to do so, a sensitivity detection and classification tools are required. The second significance of the study is for anonymizing personal information. Personal informations are highly needed for researching purpose, but it should be firstly anonymizing or de-identifying the personal information of individuals. So this is a tool, or the proposed tool can be applied as an input for anonymizing personal information. And the third significance is warning social media users before posting their sensitive information. Nowadays, knowingly or unknowingly, social media users like Twitter users, FB users, and the like publish their private information knowingly or unknowingly. So the proposed tool or model can be used for warning social media users before publishing their sensitive information. In this study, we have applied experimental research methodology, and this methodology enables us to analyze and understand the effect of different variables like our data set, experimentation, and hyperparameter setups. The data set for this work was collected through 3 ways. First, we have collected from online news page, clicks, and Twitter. Secondly, we have used other language sensitive health information data set by translating to Amharic language text. And thirdly, we have prepared additional data set by constructing sensitive personal information using a sensitivity trigger vocabularies we collected. To annotate our data set, firstly, we have prepared annotation guideline based on Minister of Innovation and Technology Data Protection Proclamation document, and this guideline was reviewed by domain experts from the Minister of Innovation and Technology Office staffs. After all, individuals were requested to annotate our data set based on the prepared guideline. And from the annotator groups, there were language experts for checking language matters. That means the grammatical correctness of our data set. At the end, the annotated data set were sent to Minister of Innovation and Technology Office for final review, and this data set was used as our final model development data set. When we see the model architecture or the generalized workflow, the input is the annotated data set, and the first component or the first module is a text pre-processing operations. A text pre-processing operations like tokenization, normalization, stop order removal, and stemming were applied first on the model development data set, and next to that word representation or word embedding models were trained, and next to this that means thirdly the model was built, trained, and validated. In the final phase is model evaluating or model testing. We have evaluated the developed model using the model developed here and the testing data set as input, and we have evaluated the model using model performance evaluation metrics. When we see a word representation techniques used, we have experimented with 3 word embedding methods: word to vec, fast text, and keras embedding layer. We have done many experiments to see their effect, and among the 3 word representation techniques, the one which performs best were selected. Word to vec was the best performed word embedding technique for the proposed work, and as we have understand from the experiment why word to vec performs best is that we have used a domain specific corpus for word to vec, and this makes the word to vec model perform best. We have also used 3 deep learning algorithms for the sensitivity detection and domain classification part, which are CNN, LSTM, and BLSTM. The literature may say BLSTM performs best over CNN or LSTM, but unless we are performed or we are checked with experiment, we cannot be sure. whether it is true or not, because those deep learning algorithms may depend the type of the application, the data set, or the length of the input. So to select the best performing deep learning algorithms, we have done an experiment for those three algorithms. When we see the dataset distribution and distribution, 7.31k Amharic sentences were used for sensitivity detection and 6.97k Amharic sentences for domain classification. And as a splitting ratio, 3 splitting ratios were tested: 80-10-10, 70-50-50, and 60-20-20. And among those dataset splitting ratios, 80-10-10 performs well, and this splitting ratio was used as the final model development dataset splitting ratio. Here is the experiment setups. 3 experiments were done for those 3 algorithms. That means for the 3 algorithms we have performed 3 experiments, and among those experiments and those deep learning algorithms, the one which perform best were selected. Here is the experimentation result. Among the 3 deep learning algorithms, our experiment shows that the BLSTM based model performs best for sensitivity detection and domain classification. And among the 3 experiments, the BLSTM performs best at experiment 2 for both sensitivity detection and domain classification. That means BLSTM scores an accuracy of 91% for sensitivity detection at experiment 2, and the for domain classification it scores 93% accuracy. And when we see the performance comparison of the 3 deep learning algorithms for both level classifications, that is sensitivity prediction and domain classification, the 3 deep learning algorithms performed best at experiment 2, as we have see from this chart. And among those 3 deep learning algorithms, the BLSTM performance based, and the selected algorithm for this study is BLSTM based on the experimentation is carried out. When we see the contribution of the study, this study did 2 basic contributions. The first one is the dataset. We have prepared an Amharic sensitive information dataset, which can be an initial point for the next or the future researchers to study further. We have also developed a sensitive information detection and classification model for Amharic text, which is a novel and no works have been proposed yet. As a conclusion, we have studied 3 deep learning algorithms along with different hyperparameter setups for Amharic text sensitive information detection and classification task. And among those deep learning algorithms, the BLSTM performance based in terms of prediction or classification performance. However, in terms of model training time, the CNN based model takes shorter training time, while the LSTM takes higher or longer training time. This is all about. Thank you for giving your time.